Welcome to Future Dr. H Numerics. Today we'll be dealing with the physical science question paper, dealing with the vertical projectile question paper, which is focused on the graphs. So I think it's very much important so that we have this type of scenario. So it says that a ball A is thrown vertically upwards at 12 meters per second from the top of the building for the first 2 seconds after ball A is thrown. Ball B is thrown vertically downwards at 5 meters per second from the top of the same building, and this is that both balls strike the ground at t seconds. Okay, so ignore the effects of air friction. The position times graph of the sketch graph for the balls are shown below. So here we are told of two balls. So we are told that there is ball A, which is this one, and then there's ball B. The difference is that you see that 2 seconds after ball A is thrown upwards, ball B is thrown vertically downwards. So here's the difference. So it means that from this is the seconds from here to 2 seconds, that's when the other ball is thrown up. So it means that here is the 2 seconds after, and then this is the time they both strike the ground. So what we get, they strike the ground at the same time it is in which they strike the ground. That's some things which is very much important. And then it says that using equation of motions only, calculate the value of each of the following as shown in the graph. So they say that 3.1.1, the t, what is our t? The t is is the time in which both of these balls they strike the ground at the same time. That's the t. So let's check which variables are we given pertaining which balls. So let's check first. We are told the initial velocity here. We are told the initial velocity of the first ball, which is what? Initial velocity of the first ball. Let me write ball A. I want us to walk through and see how we'll solve this together. So you must list the variables that you know about each ball. So the first thing that we know about these balls is that ball A, we are given its initial velocity. Initial velocity is that it's projected. Let me choose direction. Upwards is positive, up is positive, so it is thrown upwards. So it means that initial velocity of this is equals to plus 12. The positive, you can choose whether to write it or not. And then it says that 2 seconds later, after ball A was thrown, ball B was thrown vertically downwards at 5 meters per second. So this one is for ball B, which we are told here minus, because what? Up is positive, down is what? Is negative. So we are just listing the variables, and then we'll see where the variable leads us. And then now the variable which is always there is gravitational, which is negative 9.8 meters per second squared, and then gravitational, which is negative 9.8 meters per second squared. And then what else do we know pertaining this ball? What do we know? The time this ball spent in the air. The time that this ball spent in the air. So this ball, ball A, the time that is spent on the air, let's check here. So from the time that it is projected to the time in which it went down, it's gonna spend t. It's gonna spend the amount of t seconds in the sky. So it's important that we have t in our equation, because we are solving for what? We are solving for t. So if we are solving for t, it's better that we have our t here. So we are solving for it, and whatever the time that we write here on this side on ball B, we must try to write it in terms of t also, so that what we can correlate the t. Maybe we are going to have like two equations, so the two equations must have the same variables, because we can't have two unknowns, or maybe unless we are doing simultaneous, that's when we can have two unknowns. But so far we don't know where the question is leading us. We are just listing what we are told. So this is the way that you do solve each and every question. Check the variables before you'll see where the variable leads you. So the time that is spent from this ball being projected to go down, it spends how much? It spends t minus 2 seconds. So, but it's going to spend t minus 2 seconds in the air, because we note that the whole time from here to from up here to down here, in relation to t is the whole t minus 2 seconds. So that's the important part in which you have to relate. Because why? Because for the whole t includes the time in which the ball of B wasn't thrown yet, because ball A was thrown, and then after 2 seconds we see that a ball B was thrown. So you must also account that, okay, from that t we subtract 2. So what else are we told here? Sorry, what else are we told? We there's just the displacement. So there's something which is very interesting about the displacement of these two balls. This is what is interesting about the displacement of these two balls. If you check here, they are going to have the same displacement. Let me start by that. They are going to have the same displacement. Let's just write maybe m, because it's in meters, or maybe you could write change in y. It's okay, let's just write m. There's going to have the same displacement, and the displacement will be covered going where? Going down. So let me show you how the displacement is the same. For example, let's say this is the top of the building, and then the ball was thrown up like this from the top of the building, and then it comes down. Then it comes down, that ball. Note that it's just like in segment, but let's just take it as if it is continuous. I didn't write it in draw it in segment. So now when you check, this is ball A, this is the motion of ball A. This is gonna cancel this. Going up and going down is gonna cancel, and then we see that the displacement is from the height of the building to go down to the bottom of the building, which is just the motion of ball B, because ball B is just thrown from here like this. So we see that the displacement in here is equal to the displacement here. Displacement it is a displacement is final position, it is P final minus P initial. So it is position final minus position initial. So where did the ball end? It ended at the bottom of the building. This is the final position. Where did it start? It started in the initial position. When we measure here, it is the height of the building. When did the ball start in ball B? It started at the position of the building. When did it end? It ended at the end of the building, which means that the displacement is going to be the same, because we don't count the time of going up and coming down, because what is gonna cancel. So I hope you got me on how the displacement of these two balls are the same. And why is the direction negative for the displacement? The distance is covered going down. Up is positive, down is negative. So now we have our variables there. We have our time, we have our initial velocity, we have, I think we are ready to roll now. So we are solving for this, which is the time. So we are going to use simultaneous. We are solving for this and also this at the same time. So let's find an equation that both includes both. All of this, all of these are included. There's only one vertical projectile equation that includes all this, is this one. Change in y equals to vi, and then change in time, and then plus half a change in time squared. So you must, there's always a formula sheet at the end of the question paper. So you just go to the formula sheet. Let me go there really fast, and then you just check which variable do you have. So it's just this formula, but it's this one because we are talking about a motion in the y-axis, and then you just copy and paste it. But if you do problems like this continuously, the formula will just be in your head. You won't have to look it down. So this is the formula. So it's simultaneous. We are going to do equation 1, substitute ball A, equation 2, substitute ball B, and then we solve. So this is our equation 1. Equation 1, let's use ball A. Ball A. Or ball B. I'm saying ball A and I'm writing B, but it was going to be the same thing, even though we started with ball A, and then I just come and just substitute, and then this one is just going to be negative m, and then V R A. You substitute with the sign, but positive, it doesn't matter. You don't have to substitute it. But me, I'm just substituting it, and then it will be our T here. We substituted the T, and then plus half, then negative 9.8, and then it's just gonna be our acceleration, and then now it's gonna check our time, our t squared, and then now there is our simultaneous. That's the first equation. But we are solving for t, meaning that we can just make m subject to the formula. But let's just make m subject to the formula, and then we'll equate both equations because both of them they are equals to m, and then we just multiply both sides. Or let's just simplify first before we remove this negative sign this side. So it's gonna be 12t into, I wrote half two times this side. Yeah, I wrote half two times. Let me just wrap this other half. I'm sure you might have been surprised there on the other side of the screen that why is this person writing half two times. So a half 0.5 multiplied by, let me press my calculator, 9.8. So it's just gonna be negative. So let me just write negative altogether. Negative 4.9, and then it's just gonna be t squared. So that's our equation. Let's just simplify it further, multiply both sides by negative, so it's just gonna be, this one is gonna be positive now, and then this is gonna be negative. I just multiply by negative now. I just multiply by negative, and then when I come here I just say negative 12t. That's our equation 1. We are left with t only. So let's have our equation 2. Let's just scroll down. Let's not wrap yet because you are having a nice flow. Ball B. And then now when we go to ball B, we just substitute that simultaneous, and then we just come and see change in y equals to vi, change in time, plus half a change in time squared. And then we just come and write here that the time, the position covered here is just the same as that one, but here it was projected at a different speed at ball B at negative 5.4. Negative 5.4 because up is positive, down is negative, and we are told the speed in which it was projected. So here I'm just substituting. I don't have to write change in time. We are told that the t spends there. It's just our t. Let me write like this so that you can see. We just took it here. Sorry, I've caught the flu. It's winter this side, so let me just do this and plus half, and then when it comes to the acceleration, negative 9.8, and then when it comes to the time, it's just t, or t squared, t minus 2 squared. So you see, that's why it's 5 marks. There's a lot of maths here. The science just comes in applying the concept, and then after that we just deal with maths. So now let's see what's the way that we can just do and solve all this all together. So now I see there's a common factor here, there's this and this. So now let me just multiply everything by negative. Oh, if when it comes this side, I didn't have to write these steps. Let me wrap this step. Let me wrap this step. Because why? Because I can just say negative m equals to negative m and write everything as is. So you'll see why I'm wrapping this step, because I think this step it's unnecessary now, because I don't want to multiply this side by negative also. So let me just write equation 2. This is our end of our equation now. We want to get rid of m because we are solving t. Equation 2, this is our equation 1. So I'm going to say negative m equals to negative m. Now I just equate. So it's going to be 12t. I'm writing down this minus 4.9 t squared equals to, and then I just say 5.4 into t minus 2, and then I just come and say plus half. So half of this is just gonna be 4.9 if I'm not mistaken. So yeah, it's just the same there, negative 4.9, and then t minus 2 squared. So we are just left with the maths. The science is over. So now this is going to be a trinomial. It's going to be a trinomial. So now, what's the fastest way to do it? I like shortcuts, but they seem like there's no shortcut here. I just have to do everything myself, unless I can just. Uh, is there a way of, if there's a way of saying or finding t minus 2 this side, though it will be fine. Let me say t minus 2. What if we I think that there's no shortcut, so let's just multiply. There's no shortcut. Your teacher likes shortcut, ne? And then he says that t minus 4.9 t squared. I wanted to see if I can just find a common factor, and then I cancel this bracket, but there's no way of finding a common factor here. So it's not a shortcut, but just a way of working smart. So now let's just multiply this and this and this and this, and then we'll get our answer. So it's going to be just negative 5.4 t, and then 5.4 times 2. And then it's going to say 5.4 times 2. And then it's going to say plus negative times negative is positive 10.8, and then it just comes and say minus, and then this one is the one that we have to say this multiplied by this. Yeah, now we have to just do like this, t minus 2 and then t minus 2. So this is how we're gonna do. This is gonna hold this, then this is gonna hold this, and then this is gonna hold this, this is gonna hold this. So now let's just solve, and then we say 4.9, and then now we just come and do like this. We say this times this is going to be t squared, and then we say this times this is going to be minus 2t, and then this minus this is going to be minus 2t. Oh, sorry. It has to be minus 2t. Minus 2t also. This minus this is going to be positive 4. And then now, see, this is the long way, but there's no other way of that I saw in which we can do it. So now we just come and just write everything as it is. See, the science is over. You in physics, you have to know science and also know maths, because now we are just left with the maths. And the maths, you can just lose the answer here at the maths only when you are done with the science. But luckily, if they are they're charitable, they will give you some marks if you just lose your answer here on the maths. So now 12t minus 4.9. Yeah, I know if it's not that interesting anymore. Like when I am explaining the principle of physics. This times this is going to be negative 4.9 t squared. This times this, let me press 4.9 times 4. This is going to be 19.6 positive 19.6. We'll multiply it with the sign, something which is very much important. Multiply by 4 again, it's going to be 19.6 again. So now we just find it a good trinomial. So now let's choose a side where, this is good, because this is gonna cancel this. Yes, this is good, very good. So because this one is negative, this one is negative, this one is positive, so this is gonna come here and cancel. We no longer have a trinomial. I had to do the quadratic formula. So because they are both negative, if I brought this one this side, it's gonna be positive, and then it's gonna be positive plus minus negative, and then it's gonna be 0. And then now, when it comes to this, yeah, I almost made a mistake. So this multiplied by this, it's t. You see, I could have lost marks there at the maths. So when I was done with the physics, so and then now let's see if there are numbers that we can just add here. This minus this. So now 10.8 minus 19.6, and then I just come and say we have negative minus 5.4t, and then this and this is gonna give us and this is gonna give us negative 8.8t, and then t, what did I add? It's just negative 8.8 only. And then now we are left with plus 19.6t. Okay, and then the common factors, this and this and this. So now now we are just gonna be say t equals to, so t equals to, now okay, it's gonna be, let me just write everything here. So this is gonna go that side, so when this gonna goes that side, it's gonna be oh, let me bring it this side, and then it's gonna be 19.65, yeah, it's gonna be right, 19.6t minus 5.4t minus 12t, and then over what is gonna be over just the let me just add first 9.6 minus 5.4 minus 12 is just 2.2 over 2.2. Okay, over 2.2. Okay, wait, it's not over 2.2, just over this is gonna be that side, or this is gonna be that side, and then here is gonna be this, sorry, this is gonna, yeah, over 2.2, and then we just come and say 8.8, and then after this 8.8 we have our here we just divide both sides 2.2, and then we are left with t equals to 8.8 over 2.2. 8.8 divided by 2.2 is just 4. Yeah, that was a long one. It was a long one. I hope I didn't lose you. If I lost you, you can just work it out in the way that you understand. Just from the simultaneous, I know students have different ways of dealing with the simultaneous. 4 seconds. So maybe I chose the most difficult way of simultaneous. Even here, you saw that it was taking time. It was also, when I tried to do things in my head, that's when it took more time. I should have just wrote everything down. So now we got 4 seconds. I hope I didn't lose you there. And then, but we got the procedure. You first list this, and then after listing, you then continue to see which formula you can substitute into. Let's check our Z. Our Z is the time in which the ball was projected. Let's check. No, the Z is on the y-axis, is the position. So it's the position above the ground which the building is. You see, if you check here on the graph, our Z is here, is from here to here. So our Z is just the position, which is just the displacement of the ball. So it's just the displacement of the ball. So because we found different ways, we have different ways to find our displacement. This is our displacement, our negative m. So we just substitute into any formula, and then we'll get our negative m. So let's choose the one which is straightforward in both the equations. So the one which is straightforward is just this one. Yeah, I think this one is straightforward. Let's just take this and substitute. When I say negative m equals to 12t minus 4.9 t squared, and then from there you just substitute, and then you're gonna say 12 into 4 minus 4.9 into 4 squared, and then now from there on you just come here. Let me write it here, and then from now on you just whatever that you get, you just do it as negative. So let me sub to 12 into 4 minus 4.8 into 4.9 into 4 squared, and then we get negative 30.4, and then we just multiply it, and then when we multiply it, we're just gonna get m equals to 30. Gonna multiply both sides by -1, multiply both sides by -1, then we get our displacement as 30. So that's how we get our displacement as 30. So now 30.4 It's 30.4 as I wrote it here. Negative 30.4. Let me just come and write here negative 30.4 meters. But negative, it just means downwards. So it's 30.4 meters downwards. T up is positive. Downwards. And then our y. What is our y? Our y, it is the maximum height. You see, the other one was thrown up, and then when it is thrown up, this is the maximum height. It comes back again. So that is the maximum height above the ground. So now let's see how we are gonna find our maximum height. It's a very interesting one, this one. So now ish my screen is crowded. So, and I also don't wanna rub important things at the same time. So let me just rub from here. Let me rub from here, and then we'll see if we can, this space will work. So let me also wrap this. Okay, see. Okay, so I wrapped there. So now we just have to calculate our y, is the maximum height there. So what can we use to find our maximum height? So is the distance above the ground. So now obviously we're gonna use ball y to get our maximum height, and then we just come and say let's list what we know on ball y. So let me repeat this also. I ended up rubbing everything. So even me right now, I don't have the solution, but the way that I used to get to the answer, that you must also adapt. List what you know. List what you know. So when it comes to ball A, and then you just see that in ball A, it was projected upwards v initial. It is just that 12, positive 12. We're just still using up as positive meters per second. And then our v final is 0 at maximum height. If you're using from the initial to the maximum height, that's it. And then now meters per second. And then what else do we know? It's just our gravitational, which is always constant. And then what else do we know? What else do we know? We just know only those three items. But now what's different is that we know the time. We know what t represent, but this is the time for the whole motion. We are told that this is the time of the whole motion, and then it says that let's read information. Maybe there will be also a tip on the information again. Ball B is thrown vertically upwards at 12 meters per second from the top of the building, and 2 seconds after ball 3 is thrown upwards, ball B is thrown vertically downwards from the top of the same building, and both they strike the ground then. And then if we come here, let's see what else do we know about this. We know this, so let's check, is there a formula which we can use this and substitute. It's either we need to have, we are looking for the y, which is the position. So y is the position, so above the ground. So is there a formula that only has this? Is there? It's just to say v squared equals to v initial squared plus 2a change in y. So is the formula down there at the formula sheet. So if you first go to the formula sheet and check which things you can substitute. Even me, you first list your variables, and then now after listing your variables, you just go and substitute. So that's an easy way of approaching things. So 0 squared, and then initial is 12 squared plus 2 into negative 9.8, and then our y, I'm looking for it. So, and then we just come and do 0.144, and then plus this, we have been doing this one, or it's also 19.6. Let me just confirm, because I'm having a brain freeze here. And then so just come and it's gonna be negative. You see, I told you I have a brain freeze because minus this one multiplied by this is minus, and then we just bring that on this side. It's gonna be 19.6 change in y over 1.44, and then we divide both sides by 19.6, and then when after we divide both sides by 19.6, we just get our answer. So just divide by 19.6, then we get our change in y equals to, then we say 144 divided by 19.6. So we just come and say it's just our 7.34 meters per second squared. So that's our, not meters per second but meters, so 7.34 meters. So that's our y. So now let's go to where we sketch now. Let me just wrap all this because I don't need it anymore. Now we are going to the graph. They are very interesting, especially the ones that bounce and everything. So they are very interesting, and you need to learn them. And this is like a graph in a sort of way. You see this equation, this drawing is like a graph. It's like a graph, so you can learn a thing or two from it also. So now they say that on the same set of axes, scale the velocity time graph of ball A and ball B while they are in free fall. Label the graphs A and B. Label graph A and B for ball A and ball B respectively. Okay, on the same set as the velocity time graph of ball A and B while they're in free fall. Okay, so they say that clearly indicate the initial velocity of each ball, the velocity at which each ball was thrown, or the time at which each ball is thrown, and then this. So now I just come and draw the velocity time graph. So now, sorry, velocity time graph, let me just do this. This is the velocity, that's a position time, that's a position time. This is the velocity time. So the time in seconds, velocity in meters per second. So now what you have to know about velocity, let's say up is positive. What you have to know about velocity is every time the ball is going up, because this is the positive side, this is the negative side. Every time the ball is going up, it will be on the top of the graph. Every time the ball is going down, it will be at the bottom of the graph. So now that's what you have to be vigilant. So let's say that indicate the initial velocity of each ball. So let's check what is the initial velocity of each ball. So you there draw it up to scale. Then here I'm just drawing it a sketch. So this is gonna be our 12 here, our 12 meters per second. This one is projected upwards, so it's gonna start as on the top of the graph. So 12 meters per second, here is it. It's gonna start here, and then it's gonna go like this and go up until the velocity is 0. Why is the velocity coming to a point? I should have used a different pen. Let me see if I can use a different pen, because I'm drawing here. Let me see if I can arrange a different color. Yeah, let me just suit purple. Yeah, there's purple, and then yeah, there it is. So now it's come to a point where the velocity is 0. The velocity is 0 here because why? It's the maximum height. So this point here, you see this point where the velocity is 0, it is this maximum height here. This is the ball of what? This is going to be ball A. Is that time, because its velocity is 0 in the graph, it's going to be 0. This is the initial point because what? It's where it started as positive. So now let's just note what I said in the beginning, or I shouldn't wrap this. Just note what I said at the beginning. As much as the ball is going up, it has to be on the top of the graph because up is positive. So now let me also wrap this. So now let's continue with the motion. I wrapped a little bit of this, the graph. So now let's continue with the motion. What did the ball do after it reached that? It started moving, going down. Down is negative. It means now the graph has to be on this side. But this is the time. At this time where it reached the maximum height, they didn't say indicate the maximum height, but let me indicate it. This is the maximum height which we solved here. Here I didn't get the time for the maximum height. I didn't solve it, so let me just leave it. But this is the maximum height. Know it for yourself. It's where the velocity is 0. And then now let's continue up until the ball strikes the ground. So it's gonna continue, continue. So up until the ball strikes the ground. So this is where the ball is gonna strike the ground. So this one has to be longer than that one, because the distance it covered going down, and the distance and the velocity that it reached going velocity that it reached going up, and the velocity that it reached going down. This one it reached more velocity down there, so it has to be more negative here. So this is the time where in which what this is the time in which this ball is gonna strike the ground. So they are gonna strike the ground at the same time, but not at the same velocity, but they are gonna strike the ball they're gonna strike the ground at the same time. So it means even that one has to end at this place, because they strike the thing at the same time. So the time in which the other one was thrown, so is 2 seconds after. So let's start maybe from 2 seconds. 2 seconds. Let's say our 2 seconds is here. Yeah, that is our 2 second, meaning that it's gonna start here, but it was thrown. It was that ball was thrown vertically downwards. So because it was thrown vertically downwards, and it became more negative. It became more negative as it was thrown. So it means that this graph, when we draw it, let me choose another color. So I will show you. I'll try to explain after. So it's gonna start here, and then it becomes it's gonna do at the same time. So, but now we don't know whether at the final velocity which one was running faster, but definitely the one which was go. Let me check the velocity. The other one was thrown upwards with that one. So with the one which was running faster is gonna be the one we drew first. If checking the amount, so this. Okay, so now this is not a straight line. Let me rub it, because it's not a straight line. So now let me try to draw a straight line there. Yeah, you see. Yeah, now that is the straight line. So that I think yeah, that's the straight line. So now I want us to note this certain parts. So this is the velocity in which this one is going to be thrown down. So let me do this. This is the velocity of 5.4, negative 5.4. And then this is the velocity that is going to end with, they're going to strike the ground. And then this is the velocity that this one is going to end with. So here is going to end with the velocity of this one is going to end with, or we never know the velocity that both of them strike the ground. So this is all we know, but both of them strike the ground here. But if you calculate the velocity, we're going to see. So this is how the graphs are. So what I used to stipulate that the graphs are going to this other graph, this one, you see it started from negative 5.4, and then it became more negative. It is going down. It was thrown going down. So it means that it started there and it continued accelerating down. It continued accelerating down up until here. So this is what we see here. So now here, when we see is that they reached at the same time. They reached the same time, but we don't know what we do. We don't know here is that whether the 2 seconds is after the ball is reached the maximum height. If the 2 seconds is after the ball it has reached the maximum height. If the 2 second of the other one being thrown down is after, so the graph is going to be like this. So that's why I'm saying, somewhat we're just stipulating if the 2 seconds is after. So if the 2 seconds is here, I'm not. That's why I said I'm not drawing up to scale. So our graph is gonna be like this. So it depends on the stipulation, but we see that the graph here is gonna start with this same 5.4. So and then it is like this. So this is our two graphs. I hope you get it. You got to learn a thing or two about the graphs here. The important thing is that the graphs, when they are positive, you draw them on the top, but it depends on the direction. If you choose the direction, depends. If up is positive, if they are going up, if they are going in a positive direction, they are on the top. If they are going on negative, they are here on the bottom. So you have to also do some calculation. So these two, you could have calculated it also to check if it is on this side or if it is on this side. How could we have calculated? You would have just taken this, all those variables that we used to substitute the maximum height here, because it is at the maximum height, and check whether the maximum height, it is at which time. Maybe you'll get the maximum height is at 1.53 seconds, and then you will just say, okay, the 2 is after, and then you draw it like this. So you have to do some calculation. So here I was just sketching. That's why I haven't figured out whether it's this side or this side. But if we do some calculation here to check whether where are we substituting, we'll get, or where, which side of these two is the other graph. So I will see you. I will also have another video where I also solve graphs and just focus on them, and then I will teach you more on how to do graphs. If you are able to stay up until this far, consider subscribing and giving the video a like and a thumbs up. Thank you. Future Dr. H.